In 4.3, we're going to talk about two-way tables and Venn diagrams, but I've split it into two videos, so you can do one each day. Two-way tables is first, and here we go. Mutually exclusive events, A and B, cannot both happen at the same time. For such events, A or B means that only event A happens or only event B happens. They don't both happen. Now, you can find the probability of A or B with the addition rule for mutually exclusive events, where you just add the two individual probabilities up. No big deal. But how do you do this, probability of A or B, when the two events are not mutually exclusive? Now you have to deal with the fact that A or B means one or the other or both. Now, when you're trying to find probabilities involving two events, like the probability of A or B, a two-way table can display the sample space in a way that makes probability calculations easier. Here we go. When you're trying to find the probabilities involving two events, like probability of A or B, a two-way table can display the sample space in a way that makes probability calculations easier. Here we go. Consider the example about pierced ears in males and females. So, two-way table. Why do we call it that? Because there's two variables, gender and whether the ear is pierced or not. So we have two variables connected, so it's a two-way table. And you can see that each little spot is filled. You have 19 males who have pierced ears and 84 females out of the sample. And they have the total columns here and here. Okay? Easy enough. Now, we can't use the addition rule for mutually exclusive events unless events A and B have no outcomes in common. In this example, there are 19 outcomes that are shared by the two events that are male and pierced ears. If we did add the probabilities of A, we would get 90 out of 178. Okay, that goes right there. And then we would do 103 out of 178 for pierced ears. And that goes there. If we add those up, look what we get. 193 over 178. Well, that's greater than 1. Clearly wrong. So what's happened is we've double counted these 19 people. So we have a formula that helps us get around that. So we use what's called the general addition rule. Okay? It says if A and B are two events resulting from some chance process, the general addition rule says you add the probability of A plus the probability of B, and you subtract the probability of A and B. This is where they overlap. Okay? That's the overlap, either in the table, and you'll see this in the Venn diagram too, but we subtract any overlap. So let's try an example of this. Students in an urban school were curious about how many children regularly eat breakfast. They conducted a survey asking, do you eat breakfast regularly? All 595 students in the school responded to the survey. The resulting data are summarized in the two-way table. All right, suppose we select a student from the school at random. Define event F as getting a female student and event B as getting a student who eats breakfast. Okay, so A says find the probability of the complement of B. So if B means eating breakfast, the complement of B means no breakfast. Okay, no breakfast. So let's find this. So look at our total is here. How many of them didn't eat breakfast? So both males and females. So I come right here, 295. So that would be 295 out of 595, which gives me a decimal answer of 0.496. All right, so we found it. Now it says interpret this value in context. So here's how it would look. It says there is about a 50% chance, we made that a percentage, that a randomly selected student from this school does not eat breakfast. All right, so that's how you would interpret a probability. All right. But notice I included randomly selected, and then this part is context, right? A lot of context. All right, part B. Find the probability that they're female and they doesn't eat breakfast regularly. So I look at females. and they say no to breakfast. So it's 165 out of, which as a decimal is 0.277. Okay? Make sure, by the way, you make your fractions like this. Don't make a slanty line for your fraction. Now, part C. Find the probability they're female or, see the and? That's the overlap. Or means they're not overlap. Okay? They may not overlap. So I take the probability of female, probability that they don't eat breakfast, and then I subtract what overlaps, right? So the probability that they're female is going to be 275. Probability that they don't eat breakfast is 295. And we subtract females who do not eat breakfast. We subtract the 160. And it's all over the 595. Okay? So when we do that, we're following that probability formula. Remember the probability of A plus the probability of B, and subtract the overlap. So when I do all this math, I come up with 405 out of 595, which as a decimal is 0.681. All right? Example 2. All right, the table shows the number of girls or boys who can swim. Okay, TwoWay table. You can see that's not complete. And that's the very first thing it's going to ask you to do, is to complete the table. Well, hopefully you can figure this out. These two, I'm just going to add them up for my total, and I get 289. Same thing here, add them up for my total, 605. And then these two I just add down. So I get 330 and 564. All right, now, done A. B, the probability of selecting a boy. Well, how many of them are boys? C, it's just 564 out of 894. And make it a decimal, 0.631. C, probability of a girl who cannot swim. So here's the girls. The ones that can't swim, that's 216 out of 894. Make it a decimal, 0.242. 3 decimals is good. D, probability of a child who can swim. So it doesn't matter, boys or girls who can swim. At the total column, 289 out of 894 gives me 0.323. Lastly, a boy who can swim. So a boy who can swim is 175 out of 564. And as a decimal, that's 0.196. All right? Now, you will have to use that formula we discussed on your worksheet, so don't forget about it in the previous example. We used it as well. All right?